Hi, in today's video, we will dive into the essence of transformers, the groundbreaking technology reshaping artificial intelligence. In this short video, we will discover how transformers are crucial in advancing natural language processing, making machines more intuitive, and communication with them more natural than ever before. So let's get started with an overview of transformers. Transformers are part of pre-training process of large language models in machine learning. It all started with the release of the Attention is All You Need research paper that changed how language modeling is done today. The transformer architecture emphasizes long-range relationships between words in a sentence to generate accurate and coherent text. Transformers have four essential components. Let's consider an input text, Jane, who lives in New York and works as a software. The transformer pre-processes input text, converting it to numbers and incorporating position references. The encoder uses this information to encode the sentence, which the decoder then uses to predict subsequent words. The predicted word is added to the input, and the process continues until the final output completes the input sentence. Here, the final output is, Engineer loves exploring new restaurants in the city. Let's walk through these steps. The first component is text pre-processing and representation, where the transformer breaks down the sentences into individual tokens, like a composer separating the music into individual notes. Recall that tokenization breaks sentences into tokens, and that stop word removal and lemmatization are also text pre-processing techniques. These tokens then need to be presented in numerical form using word embeddings, a text representation technique. This is similar to music sheet providing a set of instructions to musicians to interpret and play. In the realm of neural networks, positional encoding is a game changer, especially for transformer models. It embeds the sequence order of words, allowing the model to grasp the context and relationships, regardless of word spacing. The third component, encoders, includes the attention mechanism and neural network. The attention mechanism directs attention to specific words and their relationships. In music, this is similar to musicians adjusting their volume in specific sections. Recall that neural networks are algorithms inspired by the human brain. The different layers of neural networks process specific features of the input data to interpret complex patterns and pass them to the next layer, just as each musician contributes to the final musical piece. Fourth component, decoders, are the unsung heroes in neural networks, turning encoded data back into understandable outputs. They're the final step in a relay race, taking the baton from encoders and sprinting to the finish line. By interpreting and synthesizing encoded inputs, decoders produce the coherent outputs that businesses rely on for decision-making. So, what makes transformers special? Recall that long-range dependencies require capturing relationships between distant words in a sentence, which can be challenging to model. The transformer's attention mechanism overcomes this limitation by focusing on different parts of the input. Going back to our previous example, Jane, who lives in New York and works as a software engineer, loves exploring new restaurants in the city. LLMs can attend to the relationship between the distant words, Jane and loves exploring new restaurants, leading to better contextual understanding. Second special feature of transformers is that it can process multiple parts simultaneously. When handling language, traditional language models are sequential, meaning they process one word at a time. Transformers are an improvement in this area because they focus on multiple parts of the input text simultaneously, speeding up the process of understanding and generating text. For example, in the sentence, "The cat sat on the mat," transformers can process cat, sat, on, the, and mat at the same time. That's all for now. More to come in the next videos. Happy learning and stay tuned.